In this video, we're going to take a look at increasing and decreasing functions. All right, so the definition of increasing and decreasing, right? If I have a function f defined on some interval containing the number c, f is increasing on that interval if for every a less than b in I, f of a is less than or equal to f of b. And then decreasing is where f of a would be greater than or equal to f of b. So it's a lot easier to take a look at this definition if we look at it on the graph. So here's the graph of a function. And first of all, when we talk about increasing and decreasing, the perspective is always from left to right, right? So we're going to start over here to the left and work our way to the right. And if the graph is going up, right, then that graph is going to be increasing. So this graph is increasing right up until it gets to about this point right here. Okay, and then it's going to start decreasing, going down, right, until it gets right around in here at this point, and then it's going to start increasing again like this. Okay, so that's what increasing and decreasing mean. It's as you go from left to right, is the graph going up? That's increasing, right? Is the graph going down? That's decreasing. Okay, so that's really all there is to the definition of increasing and decreasing. There is a test for increasing, decreasing functions, and that involves the derivative. Okay, so what this test says is that if the derivative is positive for all numbers in some interval, right, then f is increasing on that interval. And if the derivative is negative, well, then the function f is decreasing on that interval. Okay, so what this says basically is that you can look at the derivative to tell where a function is increasing or decreasing. Okay, if the derivative is positive, then the function will be increasing. If the derivative is negative, then the function will be decreasing. Let's see if I can. No, that's not what I want here. Let's see, tangent line here. Oops. Alright, I'm going to go here and change this to something else. G. Alright. And no, that's not going to do it either. Let's change this to H. Alright, there we go. Alright, we can click something here. Okay, turn that off. All right. Sorry about that. So remember what the derivative does, right? The derivative gives you the slope of the tangent line. And so here in this red function right here, I can see I've got the tangent line right here in blue. All right, so the tangent line, when the graph is increasing, right, the tangent line is going to be slanted up like that and have a positive slope. So right here you can see this line has a positive slope, right? Just remember from college algebra. So if the slope of this tangent line is positive, right, the derivative gives the slope of the tangent line, so the derivative will be positive right there. On the other hand, right, when the function is decreasing, right, the tangent line is going to be pointed down like this. Right, the tangent line will have negative slope, right? The rise over the run will be negative. And so I can tell where a function's decreasing because the derivative is negative. And then when the function's increasing back again, the derivative turns back to be positive here. Okay, so that's sort of the idea behind that test for increasing, decreasing. When the function's increasing, the derivative will be positive. And when the function's decreasing, the derivative, which gives the slope of the tangent line, will be negative. Okay. All right. So let's take a look at how we would work these problems where we want to find whether or not a function or where a function is increasing or decreasing. And just to make this one a little bit more difficult, right, I haven't given you the function f here. Okay, so all we have is the derivative. We don't even have the original function to go by. Okay. All right, so how would we find where the derivative is positive or negative? Well, what you want to do first is find the critical numbers of f, right? Remember, the critical numbers are places where the derivative is equal to 0 or undefined. So what that means is that everywhere else the derivative will have to be either positive or negative. All right, so I have the derivative here, right? If I had the original function f, I'd have to take the derivative and do all that. But here I have the derivative and it's a polynomial. So I can set it equal to 0 and solve that equation out, right, by adding the 9 to both sides and then square rooting. I get x equals plus or minus 3. All right, and since this is a polynomial, right, the domain is all real numbers. And so both 3 and minus 3 are critical numbers. So what you want to do is take those critical numbers and put them on a number line. If the domain of the derivative happens to be smaller than all real numbers, then you need to sketch just that part of the domain of f prime here. Okay, so what I've got here is negative 3 and 3. I've got my critical points on the number line like this. That's going to break the number line up into 1, 2, 3 pieces. So when you put your critical numbers on the number line, it's going to break the number line up into pieces, or the domain of f prime up into pieces. And what it turns out to be is that on each piece, the derivative is either positive on all of those points there or negative on all of them. It's either all positive or all negative, all positive or all negative, all positive or all negative. Okay? And so what I need to do is just to figure out which one it is on each piece. So to do that, what I'm going to do is pick a number on each piece. It doesn't matter which number you pick. Here I'm going to pick negative 4, but you could pick negative 5 or negative 6 or negative 7, so long as it's clearly on this piece right here. So on this piece I'm going to pick 0. On this piece I'm going to pick 4. And I'm going to take those numbers and plug them into the derivative, and really what I'm just looking for is whether I get a positive number or a negative number when I plug those in. So right here I'm going to plug in the negative 4 and I get a positive 7 when I do that. So what that means is not only when I plug in a negative 4 I get a positive 7, it means every number on this piece, I don't care, negative 5, negative 6, negative 16, negative 17, any number on this piece, when I plug it into the derivative I will also get a positive number. On this piece I had a 0, right? I picked 0 as my test point. I plugged in the 0. I got a negative 9, right? And so what that means is that not only when I plug in a 0 into the derivative will I get a negative number, if I plug in any number on this piece in between here from minus 3 to 3, into the derivative I will get a negative number. When I tested the 4, right, I got a positive 7. Okay, so that's what my number line looked like when I picked my test points. And now, right, I just put the signs over there. When I plugged in a negative 4, I got a positive. That means no matter what number I pick on this piece, I will get a positive if I plug it into the derivative. On this piece, right, no matter what number I pick in here, I will get a negative when I plug it into the derivative. And over on this piece right here, no matter what, I will get a positive if I take any number on this piece and plug it into the derivative. Okay, so now I know, hey, the derivative is positive on this piece over here from negative infinity to negative 3, and it's also, the derivative is positive on this piece, right, from 3 to infinity over here. So the derivative is positive on those intervals. That means that the original function is increasing on those intervals. Okay? Likewise, I look at the sign diagram here and I know, hey, the derivative is negative, right, on this piece right here. And so what that means is that the original function is decreasing on that interval from -3 to 3. Okay? So notice we answered all of this stuff about where the original function is increasing and where it's decreasing only by looking at the derivative. We didn't even really know what the function f was itself. Okay? So we can answer those questions just by looking at the derivative. We can go back and take a look at it. Right, that function is actually, the original function would be 1/3 x cubed minus 9x, right? And we can see, hey, that function was increasing until, right, from on this piece right here, it was going up. And then between -3 and 3, right here on the number line, it was decreasing, going down. And then from 3 to infinity, right, it was increasing again. We can take a look at the derivative, right, and look at that. X squared minus 9, that was the derivative. And take a look at the relationship of it. So the derivative is positive. What that means is that the graph of the derivative is above the x-axis right here. So we can see, hey, look, the value of the derivative is positive. That's that little plus on the sign diagram left to the left of the -3 right there. And we can see that the original function is increasing. Then between -3 and 3, right, the original function is decreasing, going down, right? And so if we look at the derivative, the green function, right, the derivative was below the x-axis right there. Okay? So the derivative was negative. That meant the original function's decreasing. Then right here at 3, right, the derivative crosses back over and now is positive. That means that the original function is going to start increasing right there. So really we analyze the behavior just by kind of looking at the diagram, or you could even look at the graph of the derivative and tell something about where the original function is increasing or decreasing.